In Lesson 7.2, we're looking at the Pythagorean theorem and its converse. You'll learn to use the Pythagorean theorem and use the converse of the Pythagorean theorem. How are right triangles used to build suspension bridges? The Talmud Memorial Bridge over the Savannah River has two soaring towers of suspension cables. Note the right triangles being formed by the roadway and the perpendicular tower and the suspension cables. The Pythagorean theorem can be used to find the measures of any right triangle. In this same book, clear back in Lesson 1.3, use the Pythagorean theorem to find the distance between 2 points by finding the length of the hypotenuse when given the lengths of the two legs of a right triangle. You can also find the measure of any side of a right triangle given the other two measures. Stated formally in Theorem 7.4, which means it's something that can be proved. In a right triangle, the sum of the squares of the measures of the legs equals the square of the measure of the hypotenuse. Or, we're used to saying a squared, which is one leg, the side opposite angle A, plus b squared, the other leg, the side opposite angle B, equals c squared. They use a lowercase c to represent the hypotenuse, the side opposite the right angle in the right triangle. Due to the curvature of the Earth, the distance between 2 points is often expressed as degree distance, using latitude and longitude. This measurement is closely approximates the distance on a plane. Carson City, Nevada is located at about 120 degrees longitude and 39 degrees latitude. NASA Ames is located at about 122 degrees in longitude and 37 degrees latitude. Use the lines of longitude and latitude to find the degree distance to the nearest 10th degree if you were to travel directly from NASA Ames to Carson City. Well, they gave us a pretty diagram, and I can see on here that from 122 to 120 is going to be 2 degrees, and from 39 to 37 is also going to be 2 degrees. We could have made it look like the distance formula and done the difference in the x's, and then we're going to have to square it. Difference in the y's, and square it, and we're going to take the square root of it. That is the distance formula. Or simpler, since we are now free to use Pythagorean theorem, we could say a squared plus b squared equals c squared. So in our case, 2 squared plus 2 squared equals c squared. 4 plus 4 is 8. So c is going to equal the square root of 8, which is 2 square root of 2. And using the calculator, that's about 2.83 degrees. Example 2 is simpler than example 1. Find D. Okay, now the only thing we really have to know using Pythagorean theorem is which side is the hypotenuse. The other two are our legs. Okay, so the hypotenuse is opposite the right angle, so my hypotenuse is 6. So I can plug in 3 squared plus, I guess I can put D if I want to, doesn't matter, equals 6 squared. So 9 plus D squared equals 36. So d squared is 27. And when we take the square root of both sides, d equals 3 square root of 3, or as a decimal, be approximately 5 point... Ooh, this is interesting, rounding to 2 places. Okay, if I go out to 3 places, it'd be 196. I've been rounding to 2 places, so the 6 is going to push my 9 bigger, which is going to push my 1 bigger, so that would round to 2 places to 2.0. Okay, but remember that the converse is just the reverse, so when they say the converse of the Pythagorean theorem, they're just switching the order. If the sum of the squares of the measures of 2 sides, or we could say legs, of a triangle equals the square of the measure of the longest side, hypotenuse, then the triangle is a right triangle. So if a squared plus b squared equals c squared, then we can conclude the triangle is right. Example 3 is going to give us ample practice in the Pythagorean theorem. They want us to verify that triangle ABC is a right triangle. But before I can test if that a squared plus b squared equals c squared, I have to find what they are using a distance formula, which is based on the Pythagorean theorem. I went ahead and counted squares since they have a graph for us. So my green side, we have 2 squared plus 10 squared equals c squared. So 4 plus 100. And I'm just going to leave that as c squared, because that's what I'm actually checking. For the blue side, 4 squared plus 6 squared equals c squared, so 16 plus 36. So 52 is that hypotenuse. And the red, we're going to have, oh, haha, it's the same. 4 squared plus 6 squared again. So that should be 52 again. Okay, so when we check a squared plus b squared, okay, without simplifying, this c would be the square root of 52. This c would be also the square root of 52. And the longest side, the side opposite the right angle, the hypotenuse, is the square root of 104. So when I check Pythagorean theorem, does a squared plus b squared equal c squared? Why, yes, it does. So it is a right triangle. A Pythagorean triple is 3 whole numbers that satisfy the equation a squared plus b squared equals c squared, where c is the greatest number. One common Pythagorean triple is 3, 4, 5, in which the sides of a right triangle are in the ratio 3 to 4 to 5. If the measures of the sides of any right triangle are whole numbers, the measures form a Pythagorean triple. So the last example that we did, where we had the square root of 52 squared plus the square root of 52 squared equals the square root of 104 squared, it was a right triangle, but this would be not a triple because the square root of 52 and the square root of 104 are not whole numbers. Remember, whole numbers are integers greater than or equal to 0. For our next example, they ask us to determine whether 9, 12, and 5 are the sides of a right triangle, then state where they form a Pythagorean triple. So I need the sum of the two smaller sides, the squares, so 5 squared plus 9 squared, I hope equals 12 squared. 25 plus 81, will it equal 144? That would be a no. So same problem, different numbers. We're checking to see if 21 squared plus 42 squared equals 54 squared. And when we square those using a calculator, we get 441 plus 1,764. And we're hoping that that sum will equal 2,916. When I use a calculator, what my rules of expectation were that this one should have worked. It did not either. So this one is also a no. They will give you some in the assignment where a squared plus b squared does in fact equal c squared, just not those. Last chance for one to work. All right, so if we do, the longest side on this is going to be 8. If we do 4 squared of 3, and if you're using a calculator, be very careful to use parentheses to get your correct order of operations, and you square the whole number, plus 4 squared equals 8 squared, I hope. Okay, 4 squared is 16, square root of 3 squared is 3. 4 squared, we said, is 16, 8 squared is 64. 16 times 3 is 48, plus 16 is in fact 64. So, yes, it is a right triangle, but no, it is not a Pythagorean triple, because they said a Pythagorean triple, they had to be whole numbers. So 4 squared of 3 is not a whole number. So even though the sides will form a right triangle, it doesn't meet the magic criteria of being a Pythagorean triple. In summary, the Pythagorean theorem can be used to find the measures of the sides of a right triangle, and if the measures of the sides of a triangle form a Pythagorean triple, then the triangle is a right triangle. Just found a mistake in the book, because we just said that this guy makes a right triangle even though it is not a triple. So what they meant to say was, if a squared plus b squared equals c squared, whether or not it's a triple, then it's a right triangle. Wah, wah, wah.